Welcome back to the Flip Classroom series. This is Math 9 and we're currently doing Chapter 5.3. I'm Mr. McKimmon and as I said, it's a flipped math classroom. We'll start off with a couple jokes here. Number one, why was the math book sad? Because it had too many problems. What's the king of the pencil case? Why, of course, that would be the ruler. And the last one, have you heard about the mathematical plant? It has square roots. All right, so Chapter 5.3, Introduction to Polynomials, Lesson 3, Adding and Subtracting Polynomials. Example number 1. Add 3x minus 4 and 2x plus 5 and simplify your answer by combining like terms. So what we're going to do here is we're going to model using the algebra tiles. As I model, I want you to recognize that I'm putting along the top row the positive tiles, and on the bottom row I will line up the negative tiles. So here we have 3x. So here's 1, 2, 3x. And I have negative 4 or minus 4. So I'll take the ones, remember the negative tiles have no shading. And it's negative 4. Again, remember that we can change this 3x minus 4. I can change that to an addition statement. 3x plus, and then I add the opposite. So it was minus 4, so the opposite of 4 is negative 4. So when I'm representing that, I have my 3x, and then here I have my negative 4. All right, let's add in 2x and positive 5. So here's 1, 2x, and we'll add in positive 5. So that's 1, 2, 3, 4, and 5. Okay, now you'll notice here that I'm able to add a positive 1 and a negative 1, and those create 0 pairs. Those can all be taken out and canceled. So when I simplify this model, I end up with 5x. That's my 1, 2, 3, 4, 5x. And I'm left with only one positive tile. So 5x plus 1, that's my answer. Notice I underline my answer, make it easy for me to find the answer on the page. Now, if we do this using symbols, I rearrange the initial statement. So I have 3x minus 4 plus 2x plus 5. Now I take my like terms, so that's 3x plus 2x and negative 4, so minus 4 plus 5. I combine these, 3x plus 2x is 5x, and minus 4 plus 5 is plus 1. Again, ending up with the same answer. Okay, so here we have show you know. Actually, I'm just going to scroll back up. I need to grab one of these and one of these. All right, let's infinitely clone these so we can play with them. All right, 2a minus 1 plus 6 minus 4a. So we'll start by representing the by representing the x. Well, we're using a here, but it's the same thing. This we had said is positive x, but in this case we're not using x, we're using a as the variable. So we have 1, 2a, and a negative 1. Now I'm going to space it out a little bit. I'm going to put it over here just because we're going to be adding some more values here. So there's my 2a minus 1. Now we add in 6. So that's 1, 2, 3, and there I have 6. Okay. Notice that we need to make sure that we line up so that we can create that 0 pair at the end. Right, negative 4a, so that's 1, 2, 3, and 4. All right, now I can find my 0 pairs. We can see that these create 0 pairs. Those are gone. This creates a 0 pair. Those are gone. And I'm left with negative 2a and 1, 2, 3, 4, plus 5. All right, next example. Just going to scroll this up a little bit. All right, so 3t squared minus 5t plus t squared plus 2t plus 1. All right, so I'm going to put the t squared at the far left-hand side. So I have 1, 2, 3t squared. I have minus 5t. So 1, 2, 3, 4, minus 5t. Now I'm adding to this 1t squared. Okay, so this what I've put so far here is my first part of the addition statement. Okay, I'm just going to erase that now. All right, so let's add in the second part right here. T squared, we're adding in 1t squared plus 2t. Let's bring in the positive t. Oh, notice we put the negative up top. Let's just drop those back down to the basement where they belong. 1, 2t, and we're going to add one positive tile. Bring that in here. All right, so let's combine terms. Here we have 1, 2, 3, t squared, 4t squared, plus, all right, we need to get rid of some 0 pairs. See you later. And we are left with minus 3t and the last little bitty 1. All right. Next, example number 2, determining the opposite expressions. What is the opposite for each of the following? All right, so we have 3x. What's going to be the opposite? Now that comes back to what we were talking about earlier when I said if you change a subtraction question to an addition question, we're adding the opposite. So if we have 3x, the opposite is going to be negative 3x. B, negative 2. All right, here we can go. Remember that on our number line, here's 0, here's negative 1, here's negative 2. Well, what would the opposite of that be? It's going to be equidistance from 0 to negative 2, but on the other side of 0. So here we came and we went 1, 2 over to the left. Now we're going to go 1, 2 to the right, and that gives us positive 2. Next, 4x minus 1. Don't be afraid. I know there are two terms. What is a two-termed polynomial called? Yes, that's a binomial. So the first one, 4x. What's the opposite of 4x? Negative 4x. What's the opposite of minus 1? Plus 1. Excellent. All right. Excuse me. Next one, D. A squared minus 3a plus 2. All right, let's figure it out. The first part, a squared, opposite, negative a squared. Minus 3a plus 3a. Plus 2 minus 2. And we're done. Let's scroll down. Show you know. What is the opposite of each expression? Pause the tape now and see if you can fill these in without my assistance. All right, first one, welcome back. A is x. The opposite of x, negative x. Next, 5 minus 3x. Well, first part is negative 5, and minus 3x becomes plus 3x. Question C, 7x squared plus 5x minus 1 becomes negative 7x squared minus 5x plus 1. All right, example number 3, subtracting the polynomials. All right, for those of you that have been in Mr. McKimmon's classroom, you all know that Mr. McKimmon hates subtraction. So let's switch it to an addition question. This can also be written as 3x minus 4, and then we need to add the opposite. Plus negative 2x minus 3. Now I want you to hold on to that because we're going to do that solution on the next page. So let's model this out right now. So 3x minus 4. Let's grab our positive tiles. So there's 1, 2, 3x, and negative 4. One, 2, 3, and 4. Now, I need to be able to take away 2x, and I'm just going to model it over here, 2x and positive 3. All right, so here's my 2x and positive 3. Can I take 2x away from our original model? Well, here's my 2x, 1, 2x. Can I take them away? Yes, here they are, and they are no longer a part of my model. Can I take my 3 positive away? Well, when I look here, all I have are my negative tiles. That is a problem because I can't take away 3 positive tiles from here unless we go back to our knowledge of 0 pairs. So I'm just going to erase this. Whoops. So I need to take 3 positive tiles away. Well, how can I take 3 positive away? If I add 3 more negative tiles, there's 1, there's 2, there are 3. Have I changed my value? Well, no, because all I've done is I've added 0 pairs, and anything plus 0 is still going to be the original value. But now that I've added the 0 pairs, I can now remove my 3 positive from the equation. So I will take those away, and I'm left with a final answer of my 1x and 1, 2, 3, 4, 5, 6, 7 negative tiles. Again, underlining my answer so that we do not have to search for your answer on the page. Okay, so now we're going to go back to what I talked about a little earlier, and we're going to add the opposite. So we have 3x minus 4 minus 2x plus 3. Now, if I add the opposite, I'm adding the opposite of 2x plus 3. The opposite of 2x plus 3, we just look at each of the terms. The opposite of 2x is negative 2x, and the opposite of adding 3 is subtracting 3. All right, simplify the following expression. You can use a model or add the opposite. I'm just going to pause the tape, or you can just pause the tape now and see if you can figure out the answer. When you hit play again, I will have both the model and the symbol solutions posted. Welcome back. All right, so what we did here is we see that it's subtraction. And again, as you remember, Mr. McKimmon hates subtraction. So we're changing the subtraction to an addition, and with the addition, we add the opposite. So we add a positive x instead of the negative x that we saw in the original equation, and then we subtract 2 instead of adding the 2. All right, so now we can simplify our terms. We have 2x and x, that gets you 3x, and then we have subtracting 3, which is a negative 3, and a negative 2, which it gives us a negative 5. So our final answer is 3x minus 5. Next, subtract and combine the second one. So we have we've added the opposite, so we have a negative 2x squared plus 3x plus 1. Let's combine our terms. 5x squared, negative 2x squared gives us a combination of 3x squared. We have negative x and 3x, that gives us 2x. And then we have our final 4 and 1, which gives us 5. Notice that I am putting little markings below the terms just so that I don't leave any out. Our final answer, 3x squared plus 2x plus 5. All right, now the model for each of these solutions. I started just by modeling the first term, and I'm going to show you the subtraction because this is a little bit tricky. Okay, so here we have our 1x, 2x, and our negative 3. So there's 2x minus 3. Now we need to take away this from the mix. But unfortunately, we need to take away this negative x. But there is no negative x listed in the model. How do we do that? Remember, we need to add a 0 pair. So we add 1x and a negative x. Now we're able to remove that from the mix. There we go, gone. We also need to remove positive 2 from the mix. So we look over and we see only negative tiles. So we need to add some 0 pairs. How many do we add? Well, we need to take away 2 red tiles, or 2 positive tiles. So we need to make sure that we add those 2 tiles. Once we've added them, we need to 0 them out. There's 1 and 2 and we've created two 0 pairs right here. Okay, now, whoops. All right, so now we need to remove from the mix, we need to remove those two positive tiles. So there they go, and they are gone. And what are we left with? Well, let's see. We have 1, 2, 3 x. Again, that's right here, 1, 2, and 3. And we're left with a new total of 5 negative tiles. So we subtract 5. Underlining the answer just so we don't have to search for it on the page. Let's try the second one. 5x squared minus x plus 4, and we're subtracting or taking away, negative 2x squared minus 3x minus 1. All right, I'm just going to pause this just for a moment. All right, so here's my initial model. I have 5x squared, 1, 2, 3, 4, 5x squared. I have my negative x, and I have my 1, 2, 3, 4. Not a bad idea when you start this to make sure that you have the initial part modeled. Otherwise, if you start removing and your initial piece is incorrect, the answer will be incorrect. All right, so now here's what we need to take out of this mixture. We need to take out 2 positive x squareds. All right, well, do we have those? Yes, sure we do. So here are the first 2, and they are now gone. Now we need to take away negative 3x, but we only have 1 negative x, so we need to add some more. So now we have how many? 2. Can we take away 3? Not yet. All right, now we have 3 negative x's. Can we take 3 away? Yes. But remember, we started with 1, so we have to, the ones that we added, we need to zero those out. So here's my negative x. My positive x and my second positive x. That makes 2 0 pairs right here. That it means that I have added nothing. All right, now we need to take 3x away. There are my 3x minus 3x, and they are, oh, I made a mistake. Oh no, that's right. There we go. Take 3x away, and we are taking 3 negative x tiles away. All right, now we need to subtract or take away a negative 1. But there aren't any negative 1s up there, so we need to add a 0 pair. And we have added our 0 pair, and now we can get rid of and remove our negative 1. So these have all been removed. And we're just going to move these out of the way and see what we're left with. Well, we have left in our mix a positive 3x squared, positive 2x, and 5 positive tiles. Underlining our answer. Why? So that we don't have to search for it on the page. And now it's time for you to go to work. Your homework for today will be pages 196 to 199, questions numbers 5 to 24. Thanks a lot, and have a great day.